So in the previous lecture, we talked about notation. So we talked about the notation that we're going to use for this course in Reg Calculus. And why I named Reg Calculus, why it's named Reg Calculus. And what exactly we're going to deal with in this course. As I said in the previous lecture, we are going to be dealing with differential equations. dy over dx equals y. Stuff like this. Or stuff like d squared y over dx squared plus dy over dx plus y equals 0. Stuff like that. Differential equations. As I stated in the previous, in another lecture, if you wish to enroll in this course, just simply answer one of the many assignments we have. I'll grade you and see if you're ready to go to this course. And if you complete all assignments and actually get a majority of them correct, you will pass this course. That's how it works. You don't need to pay anything. You don't need to do anything else. You just need to answer part of the assignments and watch the lectures in order to enroll in the course. So today we will be discussing about decision and choice and how they are both functions of time, or can be thought of as functions of time. So let me just open the notes and we can begin. So we have a guy. To begin, we have a guy. His name is Oliver. Now Oliver is a guy that doesn't have a fixed gender. So he can be male at times, he can be female at times. So he can be a she, Olivet, Oliver at times. Now, how do we describe what decision he makes between these two genders with respect to time? Of course, we can use a function of time to describe what exactly he decides. So if we're to graph his decisions with respect to time, it could be like any graph. It can be up, it can be a guy at this point. If we let this extreme over here be the guys, and we let this range over here be the gals, at this point he's a guy, and it jumps down to being a girl, and then it sort of tapers back up to not entirely a guy, and then at some point he thinks, okay, I don't want to be either of them, or I want to be both of them. That's why it's 0. And then back to being a guy, then a gal. This is called a change interval, and it is a very important thing actually, because it helps us describe the decision he makes with respect to time. At what time frame exactly? In this first time frame, he decides he's a guy. At this time frame, he decides he wants to be a girl, or she's a girl. At this time frame, she decides to be a guy again. At this time frame, he decides to not be any of them or both of them. This is actually the most important, is one of the most important ideas in this school's goal to integrate mathematics with the LGBT community, or describing decisions with respect to time. At what time frame exactly is his gender? And to extend that here further, if we let, I already mentioned in the last video that decision C is a function of time. It's a function of time. So the decision is determined by what time frame at the time. It's determined at the time. At T1, he's a guy. At T2, he's a gal. At T3, he's neither of them. At T4, he's a guy. At T5, he's a guy, a girl. Exactly. That's why we call it a function of time, because time determines what gender it is. So if we say that 1 and 2 are in gender, they both cannot have the same output. This has to be different from this. This has to be fully male, and then time frame 2 should be slightly male or not fully male. It cannot be equal to time frame, or the range of 2 time frames, or the y output of 2 time frames cannot be the same. Otherwise, it would not be a function. Now, as you've already noticed from the notations, that the derivative of this function with respect to time is the confidence. The dc over dt is the confidence, which we denote by O. The confidence. So it's the slope of the line. So if you have a graph here, this is this part here. It's this line that's tangent to the graph. That's the derivative of the function at this point C. That's the derivative at the point C. This is derivative. Right? You guys should know that. You guys should know the concept. Now, what more can we say about this equation? Well, of course, the derivative of C with respect to t must equal O, and if we have a function C here, it must satisfy this equation. Yeah, it can be any equation after all. It can be any equation. It can be any function. But what really is something about this function is that when we consider damped oscillations, right, start considering that the decisions that the person makes with respect to time is oscillatory in nature, which means it oscillates between two extremes. This is T, male, female. Well, these two are interchangeable. That's something that we emphasized in the first portions of QUEERIMATHICS, introductory queer theory. We emphasized that these two extremes can be switched. It could be any. We're not saying that the females are negative and males are always positive. Both can be different. And this is not positive and negative per se, but rather two opposites of each other. Okay, going back. If we have some oscillatory graph, so this is a sine graph, 2 sine 2x or 2t in this case. If we consider this is sine 2t. What if we have a decision or an interval that goes smaller and smaller, a converging interval, change interval as we discussed in queer theory? What if we have a convergent interval? What equation will we use? Well, as you've noticed, a converging change interval is something that goes smaller and smaller because of a retarding force or a retarding medium. When we say retarding force, it can be a wind, it can be a liquid, the spring can be pulled out, put into a liquid and let go of, and then that liquid's gonna stop it at some point. So it goes like this, smaller, 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 smaller. And this is described by the function v of t plus e to the negative gamma t sine k t. Smaller and smaller, but moving past the actual solution to the equation that I haven't even discussed yet. What is the equation used to model this kind of behavior? This, and then we have a spring, and we have a unit of mass m, and we have a displacement that's described by x. You can liken this situation to this situation, and the equation for that is d squared of x over dt squared plus alpha squared dx over dt plus beta squared x equals 0. And a squared and beta squared are constants that are determined by initial conditions in this thing. And in our case, a squared and b squared can be thought of as retarding forces on this interval, on the decisions. Now, how do we apply dampening forces to our study of decisions? Well, we can't use a liquid. We can't submerge the person into the liquid and say, oh, he's gonna stop being a guy. No, that's not gonna work. Or we can't use wind. We can't throw wind at him and then you stop deciding as a guy, or decide to be a guy. We can't do that. So how do we apply the concept of a dampening force into this situation? One simple word: doubt. I've discussed this in the notational lecture, but doubt, as we've come to know it, is inversely proportional to the decision. Okay, so C, or actually the confidence, DC over dt, as you come to know, is inversely proportional to the doubt, which I think I notated via delta. Proportional to the doubt, delta. We're saying inversely proportional because if we're to graph one with respect to another, as the doubt increases, the confidence decreases. This is it goes like that. And as the confidence decreases, the doubt increases. Doesn't that make sense? Does you guys think that makes sense? That the more you doubt your decision, the less confidence you have in yourself, and the more confidence you have in yourself, the less doubt you have in yourself. So that's that. That's doubt. That's it. That's what we apply here in order to damp this force. And delta can be likened to E, as I said a while ago, the dampening force or retarding force, e to the negative gamma t. And then we just attach the function here, the oscillatory function. It can be cosine, it can be sine, it can even be tangent, but I don't think tangent is applicable in this course. Just sine, cosine. So yeah, in summary, we use this equation to describe a dampening force, a dampening thingy, and its solution is in the form e to the negative gamma t, and a trig function, cosine, kt, so x. In this case, it could be c, because c is the decision. So that's it for this lecture. The next lecture, I will be discussing about why am I always not prepared for this? So the next lecture we'll be talking about the axiom of personality, which is axiom of personality is A equals C, where the appearance is equal to the choice or decision. And after that, we're going to discuss about the axiom of congruence, which was previously named concordance. Congruence. So the condition is equivalent to the appearance. And next, after that, flux. We're going to talk about behavioral flux. And after the flux W equation, flux variability equation. After that, we're going to discuss briefly about dynamic, then situations involving area, how some guys relate to each other via areas, and the behavior equation. And then last, I think, the behavioral diffusion equation, the situation of behavioral diffusion wherein doubt and confidence balances each other out. So that's that. I'll see you guys in the next lecture.